All right, 6.4, we're going to take a look at proportional reasoning. It's part of the title of the class you're in, Statistical and Proportional Reasoning, prop and stats, proportional and statistical reasoning. I flipped them. And our leading idea is the following. Proportional reasoning helps us understand relationships, how changes in one quantity affect another in a balanced and predictable way. In a similar way, faith in God shapes how we view our relationships with the world, others, and ourselves. It provides a sense of balance and perspective, reminding us that our actions, values, and beliefs are connected to something greater. Just as proportional reasoning brings order and consistency to mathematical relationships, faith brings coherence and purpose into life's decisions and experiences. The example that we had of I think it was Jasmine was her name in section 6.3 where she read the book, right? And we set it up as an equation, 3/4 x equals 246, that one right there. That's actually a really good example of a problem that can be done in a different way with proportional reasoning. The perspective's a little bit different. It works really well, but again, it's one of those places where we have options to tell students so that what works for us might not work for them and vice versa. We have choices, okay? So let me actually talk about a little bit this idea of these proportions. So ratios. Ratio notation is written in either this colon notation or fraction notation or words. The one that we'll see used the most is the fractional notation because we can actually compute with it and move forward, but all three are ratio notations. All three are read as A to B, okay? So you can do A to B in a colon, right, with a colon between them form, or you can do A over B and write it as A to B that way. We can actually write the words A to B as well. There's two types of ratios. There's a part to whole ratio, and then there's a part to part ratio, okay? So a part to whole ratio works like this. So let's say we're talking about the entire class here, okay? So show of hands, how many of you are juniors and seniors? Okay, I have 4. Okay, 4 of you are juniors and seniors. And if everyone's here, which I think we all are now, we have 18 people, okay? So a part to whole ratio is to say if we wanted to look at our seniors and juniors, that's 4, compared to the whole class, that ratio is 4 to 18, okay? Oh. So a portion of the class compared to the whole class. The other way we can look at ratios is a comparison of part to part of something to part of something else. So if we thought about it this way for that particular example, and if we do our juniors and seniors as that 4 still at the beginning, what we would be comparing it to instead of the entire class is the part of the class that are not juniors and seniors, and will leave me out of the equation. So I'm not included any of these numbers. So that would actually be 4 to 14. It's a part to part comparison. And again, there's connections of this into some of the stuff we're going to be doing later in the semester. We'll come back to this idea of part to part and part to whole when we look at probabilities, okay? So there's 2 different types of comparisons we can make with ratios. And here's an example of another one. So there's 15 students and 7 of them make A's on a test. The part to whole ratio is 7 to 15, right? A's compared to the whole class. The part to part ratio is 7 to 8. A's compared to not A's, okay? So it's a different way of making comparison, but both have their purpose and their connection points, and we'll see them used. We do want to be able to move from one notation into the other one, however. So if the ratio of boys to girls in the class is 2 to 3, we would like to be able to then say what the ratio is of boys to the entire class. So if we set this up, and I'm going to set them up in fraction form because it's pretty nice to do so. So in this 2 to 3, like this, it says it's boys compared to girls. So boys on top, girls on bottom, the way that this is set up, okay? So what it's saying is that for every 2 boys, there are 3 girls. Does that make sense? Like if you put them into like groups where you wanted them dispersed, you know, sort of equally, so that there's the same number of boys in every group, the same number of girls in every group, this is what you would do. 2 boys in the group, 3 girls in the group. And you go to the next one, 2 boys in the group, 3 girls in the group. Can you picture that in your head? Okay, but what we want is we want to take a ratio that's boys to the whole class. Okay, so again, this is a ratio, so I don't need to actually know the number of boys. I just need to know those ratios from before. So for every 2 boys, right, there were 2 boys and 3 girls if you compare the whole group or the whole class. So what we do is we take the numerator and the denominator and we add them together because that would be the group that makes up the same ratio that the class is in. And I would end up with 2 to 5. So I would have a 2 to 5, or you can write it in the colon notation like this if you prefer, 2 to 5 ratio of boys to the whole class. That doesn't mean that there's 2 boys in the class and 5 boys in the class, but every group that I make would have 2 boys in every group of 5. That's what that's saying. We can go the other way as well. So we can start with information about the whole class. So if I have 3/7 of the class that are girls, what is the ratio of boys to girls? Well, this one says girls, again, to the whole class. So this is 3 to 7. So again, this is talking about grouping. It can be a reduced fraction, that's fine. But for every 3 girls, there's a group of 7 students. So in this 7 students, 3 of them are girls, which means how many are boys? 4. 4 of them are boys. That makes up the 7. Does that make sense? So if I want to compare boys now to girls, I need to find the pieces that tell me about how many boys are and how many girls there are. So how many boys are there? 4. And how many girls? 3. And that's within each group, but it can generalize to the whole class because each group has the same makeup, right? It has the same collection of types of people. That's what's going on there. All right, that's a good place for us to stop. So we will pick up next time on proportion.